All right, so now we're going to work backwards and try to actually draw the graph from the information. So first we need to look at our information. So f is increasing when x is less than 0 and when x is greater than 4. F is decreasing when x is between 0 and 4. F of x is greater than 0 when x is greater than -2 but less than 3, and when x is greater than 5. F of x is less than 0 when x is less than -2, and when x is between 3 and 5. Once we draw our graph, then we'll describe the degree and leading coefficient. So how do we start with this? Well, what I would do first is I would identify that when we change from greater than 0 to less than 0, or less than 0 to greater than 0, this happens at our x-intercepts. So I know that there's an x-intercept, so each one of these values right here, these are x-intercepts, right? And they repeat. So, you know, if we put them in pairs, so I've got the 3 and the 3, and the 5 and the 5, and then the -2 and the -2. So I know that this graph has an x-intercept at -2, 0, at 3, 0, and at 5, 0. Okay, so the reason why I identify those is I'm going to actually just plot those points first. So if I come down here, I know, what do we say, -2, 0, and then 3, 0, and 5, 0. Okay, so that's my first thing. All right, and I know it's greater than 0 when x is between -2 and 3, and when x is greater than 5. Okay, and I know it's increasing when x is less than 0, and when x is greater than 4, and decreasing when x is between 0 and 4. So I know that there has to be a maximum. So if I'm increasing when x is less than 0 and then decreasing from 0 to 4, there has to be a maximum when x is 0, and then some y value. I don't know that y value, and I don't actually care about it. I'll talk about that in a second. Then there has to be a minimum. So I was decreasing from 0 to 4, and then I started increasing. There has to be a minimum when x is 4. And then, again, I don't know the y value, but that's okay. So I'm going to kind of put this stuff together. So between -2 and +3, the function has to be greater than 0, and there has to be a maximum, right? Because I know this has to happen. So what I'm going to do is I'm going to just, when x is 0, because that's when the maximum has to occur, I'm going to put a point that is above the x-axis. And so I'm just going to, let's put it right, just so we don't get confused, let's put it here. Okay? Do I know that it's that high? I don't. Do I care? I don't. I just know that that has to be a maximum. And then I know that when x is 4, there has to be a minimum, and when x is 4, the graph has to be below the x-axis. So similar to what I just did with the maximum, when x is 4, I'm going to just put a point below the x-axis, and I'm going to say that that's a minimum. Now, I just need to connect these dots and draw my shape. So I know the function is increasing when x is less than 0, right? So if I connect this, then function's got to be doing something like this, and then it was decreasing, and then it was increasing again. And so I draw that, and now let's real quick, let's check and make sure that I satisfied everything. So it's increasing when x is less than 0 and when x is greater than 4. And so here it's increasing, and when x is greater than 4, it's also increasing. It's decreasing between 0 and 4. Well, if I had my increasing correct, then hopefully I had my decreasing correct. And then the function is greater than 0 between -2 and 3. So from -2 to 3, this is positive. Okay, that's good. And when x is greater than 5, so when x is 5, greater than that, it's positive. Perfect. And then it's less than 0 when x is less than -2. Okay, that's less than 0. And between 3 and 5, that's negative. Okay, perfect. Awesome. Nailed it. So next thing is describe the degree. Well, since I can see that the end behavior is down left, up right, I know that the degree has to be odd and the leading coefficient has to be positive. That was fun. All right, I want you to try. Don't get thrown off by the fact that there's some decimals here. So see if you can sketch this graph. Pause the video. Unpause when you're ready to check. All right, so hopefully your graph looks something like this. It doesn't have to be exactly the same. And in fact, it might not be. There's just a few things that we have to have the same though. So the first thing, again, I found the x-intercepts. How did I do that? Because I looked at where the function is changing from greater than 0 to less than 0. So -3, 1, and 4. So I marked down -3, 1, and 4. Those are my x-intercepts. That's where it's changing. And then I looked at where it was changing from decreasing to increasing. And that was at -1.5 and 2.5. And so I knew -1.5 was a minimum because I went from decreasing there to increasing. So if I change from decreasing to increasing, that's a minimum. And then at 2.5, I went from increasing to decreasing. I'm sorry, this is the increasing to decreasing. So that had to be a maximum. And just to kind of, draw that out. So decreasing or minimum, looks like this shape, and increasing with a maximum, and then to decreasing, right? So that's increasing and then decreasing, and then the minimum is decreasing to increasing. So then I remember when we plot these, we don't know the y-coordinate. So we just kind of pick a y-coordinate as long as it satisfies the other requirements. So I know from that the graph is positive when x is less than -3. So this is positive here when x is less than -3. It is negative between -3 and 1. So I just need this to have a negative y-coordinate. I don't care where it is. I said it was at -1.5, -2. But you could have gone further down, could have gone less. It just needs to be negative. So this was negative. Then I was greater than 0 between 1 and 4. So this has to be just somewhere positive. So I just picked 5. 2.5, 5. Maybe it's right, maybe it's not. Doesn't matter. And I shouldn't use the word right or wrong. It is right. I'm satisfying the requirements. Right? There are many correct answers. This just needed to have a positive y-coordinate at the x-coordinate of 2.5. And then I'm satisfying that the function is decreasing then from 2.5 to infinity. Here it is greater than 0. Here it is less than 0. So I'm meeting all of my requirements. Then to describe the degree, so I can see the end behavior is up left, down right. So in this case, again, the degree is going to be odd, but this time the leading coefficient is going to be negative. Okay, so just to wrap that up, make sure we understand increasing intervals as we go from left to right. The x values are always going up. What are the y values doing? They're going up. If we're increasing, they're going down if we're decreasing. Relative max and relative min, this is where we change from increasing to decreasing or decreasing to increasing. And it's a maximum if we go from increasing to decreasing, and a minimum if we go from decreasing to increasing. This notation is saying that the y-coordinates are positive because they're greater than 0. So another way to say that is we are above the x-axis. Here we are below the x-axis. And all of these are intervals except for the maximum and minimum, which are points.